Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about application of first law of thermodynamics. There are several applications of the first law of thermodynamics in science and engineering. Some of the examples are described below. Heat engines. What is heat engine? The heat engine is the most common and practical example of the first law of thermodynamics. So, what is heat engine? A heat engine is a device that converts thermal energy into mechanical energy and vice versa. A heat engine consists of a cylinder-piston arrangements with working fluid. The application of heat and pressure produces work by the piston. When piston is moving up and down, work is done. Let us understand how it's work. When heat is supplied to the engine, the working fluid, that means maybe in diesel engine, petrol engine, it is a mixture of fuel and air. The working fluid absorbs the heat and then expands in volume so that the piston moves slowly upward and mechanical work is produced. Some amount of heat also radiates from the system, which will be discussed again in the second law later. The working fluid exerts pressure due to its volume expansion. In a cylinder, volume is expanded. Due to pressure increase, the volume is increasing. While the piston move upward, that work is done, which exerts a force on the piston surface, causing it to travel downward, and that means what the cycle is continuous. This movement can be used to provide a work equal to the total force applied to the top of the piston multiplied by the distance traveled by the piston. That is, work is PdV. Another example, refrigerators or air conditioners. Another practical application of the first law of thermodynamics is in refrigerators and air conditioners. The refrigerator is a device that draws heat from a low temperature sink to a high temperature source. That means inside we need a cooling volume and area. That means inside heat is get out by using external sources. Then that means what heat is delivered to the higher temperature medium. It consists a compressor that uses mechanical energy to compress the refrigerant fluid from the evaporator in the gas phase. With this compression, the pressure and temperature of the refrigerant fluid increases. When it enters the condenser, the refrigerant transfers the heat to the environment, causing the temperature to decrease and condensation to occur. This is the process of phase change from gas to liquid. After that, the refrigerant fluid passes through the control element, capillary tubes or expansion valves, which by narrowing the passage slow its speed on the evaporator, causing its pressure to decrease. The refrigerant fluid arrives in the liquid state and under low pressure to the evaporator, during which it changes phase again from liquid to gas. After a phase change, it absorbs the heat present in the conditioned items in the refrigerator, cause the returns to the compressor, restarting the refrigeration cycle continuously. Next is heat pump. A heat pump has the same application as a refrigerator. The working principle is also nearly same as the refrigerator. Heat pumps can also transfer heat from low to high temperature sources. Heat pumps can be reversible or irreversible. Reversible heat pumps are commonly used as refrigerator. Further explanation of application of first law of thermodynamics. When a process is executed by a system, the change in stored energy of the system is numerically equal to the net heat interactions minus the net work interaction during the process. That is E2 minus E1, energy different, is equal to Q minus W. Therefore, delta E, that is E2 minus E1 is delta E, that is Q minus W, or we can say Q equal delta E plus W. Now we can say this in terms of integral 1 to 2, path 1 to 2, d of Q minus W is equal delta U. We can say it is U2 minus U1. Therefore, Q minus W equal to delta U, that is U2 minus U1. Next one, energy, we can explain energy as a property of system. Energy, which is a property of system. Consider a system which changes its state from state 1 to state 2 by following path. For example, look at here. This is pressure axis, this is volume. Now, 1 to 2, the path first is this 1 to 2. Then it's written in two ways here. Written like here, say M, and one more way, it's written like. What do you understand this figure here? Consider a system which changes its states from 1 to 2 by following the path L. First path is, suppose it is L. And returns from 2 to state 1, first path L, and return to state 2 to 1 following the path M. So the system undergoes a cycle. Writing the first law, we can say del QL equal delta AL plus del WL, and for path M, this is for path M. Same path for path N also same. Here the process L and M together constitute a cycle that we can say integral sum delta W equal integral sum delta Q. Therefore, WL plus WM equal QL plus QM. Therefore, QL minus WL equal WM minus QM. Similarly, had the system returned from state 2 to 1 by the following path N, by path M, we can say delta EL equal minus delta AL. therefore you can say delta AM equal to delta AM. What you notice here, thus it's seen that the change in internal energy between two states of a system is the same whether path the system may follows in undergoing the change of state. That means here the system is same here when the path changes other. That means what, it is irrespective of the how it returns to the path by path. These are some examples of first law of thermodynamics application. Next one, perpetual motion machine. What is perpetual machine? Once the machine was started, it won't stop. Is called a exactly perpetual motion machine, but it is not possible practically. The first law of thermodynamics states the general principle of the conservation of energy. Energy is neither created nor destroyed, we know that, but only gets transferred from one form to another. There can be no machine which would continuously supply mechanical work without some form of energy disappearing simultaneously, such as fictitious machines is called perpetual motion machine of the first kind. Next is energy as an perpetual machines. Look at here. This here, suppose it is an engine. Heat is applied, work is out. Another machine, same another kind. And that work is done on it and Q is out. That means it's convertible. 100% it is not possible. Some extent it possible. That is perpetual machine is theoretical machines. So far we discussed about some application of a first law of thermodynamics. In further videos will come detailed explanation. We have done. Please subscribe our YouTube channel.